So the last lesson of this unit will be about solving polynomial inequalities. Now, why we devote a separate section to this is that polynomial inequalities is a class of inequalities called nonlinear inequalities. And when your inequality is nonlinear, you have to use other techniques. Why is that? Well, let's recap or recall linear inequalities. For example, let's say we had something like 2x minus 4 is strictly less than 8. When you have a linear inequality, you basically treat it like a regular equation with one special rule. Anytime you multiply or divide by a negative number, you have to reverse the inequality symbol. But aside from that, it's your regular algebra inverse operation. Do whatever you need to do to get the variable by itself. So you would add 4 to both sides, and then divide both sides by 2, right? No fuss, just very straightforward solving for x. Now, we can't do this for nonlinear inequalities because it's difficult to isolate the x when you have multiple x terms. So if I had something like this, x squared minus 4x is less than or equal to 9, because you have multiple x terms make it difficult to isolate using only inverse operations. So this is our dilemma, okay? How are we supposed to solve for x in an inequality if we have multiple x terms? The idea is use its graph, right? If you have a graph of a function, you can easily solve any polynomial inequality because of one theorem called the intermediate value theorem. Now, you don't need to know the statement. I'm not going to quiz you on the definition. It's a very obvious definition to convince yourself. Even if this is not a formal proof or anything, it's easy to convince yourself of this fact. Let's take a look at the generic graph of polynomial function. That we did a whole bunch of that yesterday. And I hope you guys notice, I'm just going to draw a whole bunch of random squiggles here. Say I had something like, here it squiggles up, maybe it squiggles down this way, right? Well, in any polynomial, if you focus on the x-intercepts, you notice that we have parts of the graph going above the x-axis and parts of the graph going below the x-axis. So what I've highlighted in yellow here, I hope everyone can agree, are parts of the graph that are above the x-axis, and the parts I highlighted in pink here are parts below the x-axis. Well, if a function is above the x-axis, right, these are the positive values of the function, and the parts that I've highlighted below the x-axis, these are the negative values of the function. Consequently, if I just look at the x-axis, the parts that I've boxed, I hope everyone agrees, are the x values, in this case, that produces positive values of the function. And I'll do the same thing here. The parts that I've blocked off in pink, and I'll leave this one open because this guy goes on forever. The parts I've blocked off in pink are x values that produces negative function values. So one of the consequences of the immediate value theorem is that the x-intercepts, they will sort of chop up any polynomial function into positive regions and negative regions. And we're going to exploit this attribute of x-intercepts to develop a technique to solve any nonlinear inequality. So these are sort of like tips, or let's call them guidelines. Guidelines to solve polynomials inequalities. Anytime I solve a polynomial inequality, I want to make sure you have 0 on one side. So you want to move all terms to one side of the inequality so that you have a 0 on one side. Okay. So you want one side of your problem to be a 0. Once that's true, you're going to pretend you have an equation. So pretend you're not solving an inequality, but pretend you're solving an equation and solve. Right. Now, we've learned various methods of solving polynomials. The first thing I always try is factoring. Right. Be it quadratic factoring, be it factor by grouping, so on and so forth. If that fails, you can always do P's and Q's. Once you factor everything, or once you solve it, you're going to produce a sketch, the polynomial. And sometimes you don't have to go all the way. I'll put a little asterisk here because we can do a sort of an abbreviated graph called a sign diagram. I'll show that later. And then once you sketch it, you're just going to read your answer. And your answer will be dependent on what type of inequality you have. If you have your inequality being greater than 0, that means you want positive values. You want to find the intervals that give you positive values. And if your problem is less than 0, it means the exact opposite. It means you want regions or intervals that give you negative values. So these are I'm not saying it's the only way to do it, but these are my 4 steps on solving any polynomial inequality. So let's just go ahead and do a few examples here. Suppose I ask you to solve, let's start off simple and we'll gradually increase our way up here. X squared is less than or equal to 5x minus 6. So you can see it's a quadratic. Now, we've solved quadratic equations before. That should be easy. The only difference between today and then versus our previous lessons is that I've changed the equal sign into an inequality. That's it. So step number 1 is I want 0 on one side. It doesn't matter what side I have 0 on. Well, this is not 0. This is not 0. That means I got to move pieces around. It doesn't really matter which side I move things on. However, I like the degree, the guy with the biggest exponent, to be positive. So since the biggest exponent is x squared and I want to keep him positive, I'm going to move everything to the left. That means I'm going to subtract the 5x and I'm going to add the 6 over. So when we do that, we get x squared minus 5x plus 6 is less than or equal to 0. The moment I have 0 on one side, I'm happy, I'm good. That means I'm going to pretend that this is an equal sign. So I'm going to, sort of scratch work on the side here. I'm going to pretend, or I'm going to think x squared minus 5x plus 6 equals to 0. And I'm going to solve that however I want. It's a quadratic, so I can use complete the square, quadratic formula, but I always try factoring first. And in this particular example, this guy is factorable. So what do we have here? We have, what is it, -3 and -2. So we get x equals 3 and x equals 2. And basically what you want to do is do what you did yesterday. We can sort of sketch this guy, but we're going to do sort of an abbreviated sketch. This is called a sign diagram. You basically run through the motion, except you don't actually have to draw the squiggles. You just use pluses and minuses in place of the squiggles. Now, if you don't like to do a sign diagram, if you think this is something different and you don't want to remember doing something new, just go ahead and draw the squiggles. No, it doesn't really hurt anything. So I'm going to go ahead and do my number line here. Plot my x-intercepts. Now, I don't really draw tick marks here, just draw them wherever they are convenient. So let's call this a 2 and let's call this a 3, right? Now, whether or not these guys are open or closed, notice I put circles on the x-intercepts. Whether or not they're open or closed will be dependent on the inequality. So you will have closed circles, excuse me, if your inequalities have the or equal to bits. They will be left open if you don't. So in this case, we have closed circles. Next, I want you to graph this guy. But again, you don't really have to go through the motions. I just care about if it's positive or negative. So we'll do what we did yesterday. The first thing I want to do is find the leading term. Well, in this case, since it was in standard form, I know the leading term is x squared. So we have an even degree, a positive leading coefficient. That means my end behavior will be up on either side, right? Well, up. Things that go up, that tends to make us think positive. So I know on the sides here, he'll be positive, right? I know he'll be above the x-intercepts. So now all I have to do is figure out the middle here. Well, to do that, we use multiplicities. I hope everyone agrees that this guy has a multiplicity of 1, which is odd. And what does odd mean? It means your graph will cut through. Well, when it cuts through something, that means your signs, pluses and minuses, will change. So that means if I read from left to right, see how this is positive? Well, because it will cut through 2, he's going to change symbols into a negative, right? Because we know if the end behaviors are going up, I need to cut through before going back. See how the middle region is below the x-axis, so I know that this guy here has to be negative. So this right here is what we call a sign diagram. It's basically doing everything we did yesterday to graph the polynomial, with the exception of the actual graphing. So now what is my answer? Well, I mean, this is great and all, but I can't submit this as my answer. Well, you have to read the inequality that has a 0 with it, because less than or equal to 0 means negative values. My answer will be the negative portion of the sign diagram. And I hope you guys can see that it means this guy here. Right? So this guy means negative. So that means this is our answer. But of course, we can't just, again, leave this picture as a final answer. We actually have to write it out. So the practice and the tests on Friday will ask you to write your answer in interval notation. And interval notation is just reading what you highlighted from left to right. Do you see here how we highlighted from 2 and we ended up at 3? So we'll write our answer as every single x value starting at 2, comma, ending at 3. Remember, if your point is a closed circle, use square brackets. If it's open, use a parentheses. So there we go. There's our answer. So that's basically it. To solve the inequality, you just go through the motions of graphing, short of actually graphing it, and then just highlight the intervals of x's that contain either the positive or negative numbers that you're looking for. Let's do a couple more examples. Hopefully you guys get the flow of things. So let's say I ask you to solve the inequality x minus 1 squared, x minus 3 is less than 0. So step 1 is already done for us, right? Step 1, we have a 0 on one side, so that's good. I don't have to do any moving. Now step 2 is you want to solve this guy, solved by factor and so on and so forth. Now see how it's already in factor form for us? So we can just go straight to what we did yesterday, right? I know that the x-intercepts are x equals 0, x equals 1, x equals 3. What are his multiplicities? 0 has a multiplicity of 1, 1 has a multiplicity of 2, 3 has a multiplicity of 1. Again, I don't really care about the numbers. All I care about is if it's odd or even. So now I need to find my end behavior, so I need my leading term. So my leading term is multiplying out all the front bits. So I need to multiply the x with his exponent of 1. I need to multiply this x with his exponent of 2. And I need to multiply this x with his exponent of 1. So that gives me x to the 4th power, which, knowing our polynomial end behaviors, tells us that the graph will go up on either side. So I can do my sign diagram. So I have x-intercepts of 0, 1, and 3. Look at your inequality. Because it doesn't have a line underneath it, these guys will remain open. I do not fill them in. So knowing that my end behavior is up on either ends, I know at the very end he's going to go up, so it's positive. Right? So then let's just go ahead and trace the graph. Right? If I were to imaginary trace the graph, I hit the x-intercept of 0. Since the 0 has an odd multiplicity, that means he's going to cut through. Well, if he's cutting through, that means this guy here will be a negative number. Actually, let me use a different color here. Right here, so plus, negative here. But then he has to curl back up to a 1. Well, 1 has an odd multiplicity, or excuse me, even multiplicity. So that means he's going to bounce off. Well, if he's going to bounce off, he's going to stay down underneath the x-axis. So this guy will stay as negative. Then he's going to curl back up to a 3. 3 has an odd multiplicity, which means he's going to cut on through to the positive region. Right. So this is what I mean by a sign diagram. I drew the dotted lines to show you what it would look like if we graphed it. And again, if you can't do this in your head and you need to graph the actual function, go ahead and take the extra 5 seconds to graph it. I'd rather you have a messy sign diagram, but the right pluses and minuses. So all that's left to do is just answer our questions, right? What parts am I looking for? I'm looking for less than 0, which means negative numbers. So I'm going to highlight the regions that have a negative in them. This guy here had a negative. This guy here had negative. Now our answer will have 2 pieces, even though it looks like 1 because they're right next to each other. Because this is an open gap, I cannot connect my shading. So my answer will have 2 pieces. Well, let's do the first shading. Actually, I'm going to color code this. There we go. So our answer will be the yellow region. What number does the yellow region start at? It starts at 0, comma, where does it end at? It ends at 1. Because these guys are open circles, I'm going to have to use parentheses here. Because I have another region, anytime your answer has multiple pieces, you have to glue them together with the symbol called a union. Just basically a big U without a tail. And then you just go ahead and tack on the second answer. Well, what does the second shading, the pink shading, start at? Starts at 1, comma, and where does it end at? Ends at 3. Since these guys are both open circles, use open parentheses. There is our answer. So that's basically it. Polynomial inequalities. It's just putting everything that we've learned up till now all together in one problem. We learn about factoring. We learn about graphing. Just do all the motions, make your sign diagram, read your answer. Let's go ahead and do one more example. Let's say I ask you to solve 2x cubed plus x squared plus 6 is greater than or equal to 13x, right? So this should be like, standard example. The first thing I want to do, step 1, is you want 0 on one side. So I think it's clear to everyone, I hope, that the first thing we need to do is subtract 13x from both sides. We need to move this 13x to the left. So you have 2x cubed plus an x squares minus 13x plus 6 is greater than or equal to 0. Now that we have that, we're going to think or pretend that this is an equal sign. So we got to solve this guy here. Well, let's go ahead and solve it. It's a 4-term polynomial. So the first thing you should always try when you're solving a 4-term polynomial is factor by grouping. But try, you just simply can't. This guy is not groupable. It will not work if you try to factor by grouping. So we have to turn to our method of last resort. If factor by grouping doesn't work, we have to turn to our P's and Q's. So our P value of 6, that's 1 and 6, 2 and 3. Our Q value of 2, that's simply 1 and 2. So our list will be every single number, P and Q, P over Q I can make. So we have, let's divide everything by 1. So we have plus or minus 1, 2, 3. Being lazy here. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So I'm done with the 1. Move on to the 2. So divide everything by 2. Plus or minus 1/2. I don't have to write 2 over 2. Plus or minus 3/2. And I don't have to write 6 over 2. So that's their entire list. So we're just going to guess and check, right? Now, obviously, you would spend time on your own trying to figure out what it is. Since these are your notes, you sort of figured out ahead of time. But if you were to guess, I don't know, let's guess 2. Why not? I wonder if it'll work. We'll see that it does. So 5, I'm just going to fast forward and correctly, quote, guess for us. -3, -6, 0, as we expected. So our problem starts with an x cubed. So these guys start with an x squared. What we need to solve for is 2x squares plus 5x minus 3 equals 0. And notice that this is a regular quadratic now. So since it's a regular quadratic, you don't need any fancy P's and Q's, just solve it like normal. Solve it by factoring. And if it's not factorable, you can always use the quadratic formula. Well, again, I picked this examples for a reason, because it is factorable. 2x and an x. It's going to be 2x minus 1 and an x plus 3. So that gives us x equals 1/2, x equals -3, and of course we can't forget what we guessed, x equals 2. I hope everyone can agree that each of these answers only show up once. They have a multiplicity of 1, which means odd. So now I can make my sign diagram. So we have an x-intercept of -3, 1/2, 2. Let's check our inequality. Because our inequality has a little line underneath it, we need to fill these guys in. And, oh, we need our end behavior. So our end behavior, since the leading term is 2x cubes, we have an odd exponent, positive leading coefficient. We should know that odd exponent, positive leading coefficient is down to the left and up to the right. So in the far, far, far left, he's going to go down, negative. In the far right, he's going to go up, positive. So then let's just go ahead and sketch it. Since I know he's going to be down to the left here, he's going to go to -3. -3 has an odd multiplicity, so he's going to cut on through and curl back down. 1/2 here has an odd multiplicity, so he's going to cut on through, curl back up. 2 has an odd multiplicity, so he's going to cut on through. Well, we can see that this region here, the graph is above, so he'll be a plus. This region here, the graph is below, so it'll be a minus. What are my answers? Because my inequality is greater than or equal to 0, I'm looking for positive regions. So I have this positive region and this positive region. So let's go ahead and write our answer. So we have 2 parts, so I'm going to need a union eventually. So the first part of the answer here, our highlighting starts at -3, comma, and it ends at 1/2. They're both closed, So we'll use square brackets. I do have another piece, so I need a union, and I need to write the pink interval. This shading starts at 2 comma, and notice how there's no ending here. This thing, if I could, it would go on forever. So it would go to infinity. The 2 has a closed circle, so that'll be bracket, and infinity, since he can never ever stop at infinity, infinity keeps going forever, infinities are always open. So that is the solution to that inequality. So this unit this section 5.9 is a culmination of everything we've learned in the entire unit, putting it all together to do one task, solving polynomial inequalities. Give it a try. Good luck.